So lesson 2-1 is integers and rational numbers. For the warm-up, we want to graph each set of numbers on the number line. Okay? So we've got two sets here, and we've got 10, 40, 30, and 20. And what do you notice about all of those numbers? They're all multiples of 10. So I went ahead and I'm counting on my number line by tens. Is everybody clear with that? So when you plot the numbers, you just put 10, 40, you just put a dot on it, 30, and 20. Simple as that. Now on the second one, I still counted by tens, but you see that we've got a 5 and a 15 there. Where am I going to put that 5 and 15? Right, so it's just going to go right in the middle, right? So here we've got 10, 20, and then 5 is going to go right in the middle, and then 15 is going to go right in the middle there. So example 1 is use integers to represent quantities. So first question I have for you is, what are positive and negative numbers? All right, so this is what you said. You said negative numbers have a minus sign in front. Negatives are less than 0. Positives are greater than 0. If there is no sign, the number is positive. Negatives go infinitely to the left on a number line, and positives go infinitely to the right on a number line. Very good. Now, what does this look like? Okay, so here we've got a number line. So here we have a number line. And on that number line, we've got some negatives on the left, we've got some positives on the right, and we've got 0 right there in the middle, okay? So, we said that the negatives are less than 0, and negatives are less than 0. Positive integers are greater than 0. Positive integers are greater than 0, and 0 right there is neither negative nor positive. So, what is an integer? We said that these negative integers are less than 0. We said positive integers are greater than 0. And we said 0 is neither negative nor is it positive. So what is an integer? Good. So integers are all of the positives and all of the negatives. So all of the positives, you guys know as whole numbers, right? You know those as whole numbers. 1, 2, 3, 4, 5, 6. 0 is also a whole number. So it's the set of whole numbers. Their opposites. So the opposite of 1 is negative 1. The opposite of 2 is negative 2. The opposite of 3 is negative 3, and so forth, okay? So integers are all of the positives, their opposites, which are these, and 0. Those are all of the integers. What do you not see in the set of integers? You guys, what you don't see here are the fractions and decimals. Those are not whole numbers. Those are not integers. Just the whole numbers, their opposites, and 0. So in this example, it says the lowest elevation in North America is Death Valley National Park at 282 feet below sea level. We want to know what integer represents this elevation. So, the important information that we want to highlight here and what you're going to be writing down in your notebook is what? So this is the important information that you're going to write down in your notebook. 282 feet below sea level. Okay? Now, so, yes, what he said was true. Sea level, let's make sure we note this. Sea level on the number line is 0. Okay? This is below the sea level, right? So is that going to be a positive or a negative?
Negative.
That's going to be a negative. Okay? And the important number, of course, is 282. This is what I want you to have written in your notebook. So what integer represents this situation? Negative 282. We don't say subtraction, we say negative. Okay? On this example, we want to circle the integers in the following set of numbers. So I want you to write your instruction and I want you to write those numbers. Here, the integers are -8, -3, 12, and -15. Is everybody clear?
Yes.
Remember we said fractions and decimals are not integers. So for this one, it says, in a recent month, Seattle had 4 more inches of rain than normal. What integer would represent this situation? Now, first of all, we want to write down the important information. So what is the important information in this situation? So here, the important information is 4 more inches of rain than normal. So normal would be at 0, right? Or whatever it is, right? 4 more than that would that be positive or negative?
Positive.
Right, this would be positive. So the integer that represents 4 more inches would be positive 4. Is everybody clear? And of course, do I need to write that plus sign in the front?
No.
No. So we're just going to write 4. All right, so for example 2, it says plot integers on a number line. Now, we talked about this on the warm-up. To plot an integer on a number line, what do? We put a dot. Very good. So we're going to place a dot on the number at its location. Okay? Now, here, you guys, we have a horizontal number line and we have a vertical number line. You guys know the difference between horizontal and vertical?
Yeah.
Okay. Very good. Now, so what do you notice about the difference of these two number lines? On the vertical number line, okay, the positives go up, okay? The negatives go down. On the horizontal, the negatives go to the left and the positives go to the right. Very good. So when we plot, remember, you just place a dot on the number at its location. So for -3, we're right there. For -5, we're right there. -1, +1, and 0. All right, so for example 2b, it says what integers are plotted on the number line. Okay? So here, just to identify it, all you're going to do is look at where the dot is, right? And then identify that location, identify that number. So this one is -4. This one is
-1.
very good. Does everybody see that there's no number there, but there's a -1 between 0 and -2. And then this one is positive 2. Is everybody clear with that? Now, what do you notice about the positives and the negative numbers on the horizontal number line? So for example 3, we want to plot integers on a vertical number line. We want to plot integers on the vertical number line. And remember, this one over here, the one going up and down, this one is vertical. Okay? So, we want to plot the numbers, the set of integers, 2, negative 3, negative 1, 0, and 4. So, we just put a dot at the location. So 2, positive 2, that's above 0, right here. Negative 3 is below 0, down here. And then negative 1 is also below 0, right there. 0 is an integer. It's not positive or negative. And then 4, positive 4, is way up there. So on this example, we have a number line, another vertical number line. And what are we counting by? No. We're counting by 4s, okay? You have to be careful when you are plotting on your number lines. When you're given a number line, you need to make sure you're paying attention to what you're counting by, okay? So here we want to plot the set of integers on this number line. And so we've got a negative 2. So here's 0. Here's negative 4 down here. Where's negative 2? Isn't it right in the middle, right? So negative 2 would be right in the middle. Like right, you can just estimate where you're putting it. So that would be negative 2. Is everybody with me? What about 6? 6 would be in the middle, in the positives, right? So that's 4, 5, 6, 7, 8. So that would be right in the middle of 4 and 8. Right there. So that would be 6. How about 1? Right. Now, if you look at this one, now if you think about it, you know that 2 is going to be right there, right in the middle, right? So 1 is going to be between that green line and 0. Does everybody understand that? Yeah. So that's how you are estimating where you're going to put it. Okay, so you're splitting things in half. So there is going to be positive 1. How about negative 7? Closer to the 8. And we're going to do the same thing that we did up here with the 1, right? So 4, 5, 6, negative 6 would be right here where that green line is, right? And then between that negative 6 and that negative 8 would be negative 7, right there. So that would be negative 7. Is everybody understanding? And then negative 3, of course, we already have, this one is, wait. Down here, we already have negative 2 here. And negative 3 is going to be between negative 2 and negative 4. So negative 3 will be right there. So that is negative 3. All right, so now we're going to talk about rational numbers. Previously, we were talking about integers. Now we're going to talk about rational numbers. Now, a rational number is any number that can be written as a fraction, a over b, where a and b are integers. So, 1/2 is a rational number. 2 1/4 is a rational number, because we can write this as an improper fraction, right? That's going to be 9/4. So that's going to be a over b, 9/4. Down here we have a decimal. We have 0.45. That's 45 hundredths. Is everybody with me on that? So we can write that A over B, 45 over 100. You see? Percents. That percent can also be written as a fraction because a percent means per 100. So that's going to be 18 over 100. And then over here, negative 3/4, that's A over B. That's a rational number. For integers, do you see the circle for the integers, the oval for the integers, is also in the rectangle for the rational numbers? Does everybody see that? So that means that integers are also rational numbers. Does everyone see that the whole number circle is in the integers oval, which is in the rational numbers rectangle? That means that whole numbers are integers and they are rational numbers. You see? They're all in the same set. And of course, natural numbers, 1, 2, 3, 4, 5, and things like that, are whole numbers. Whole numbers are also integers, and integers are also rational numbers. Is everybody clear with that?